Good morning and welcome everybody. My name is Gary Jesh and I'm with Power Transmission Engineering, and I'd like to welcome you all today to our webinar presented by DieQua and Power Transmission Engineering. We're going to learn today about the benefits of a high-performance servo worm gearbox as seen through the eyes of our presenter, Tom Kahn, the Director of Business Development and Motion Products over at DieQua. Presentation is going to run about 45 to 55 minutes, and it's going to be an interactive presentation also. What I mean by that is that when we get close to the end of Tom's presentation of his slides, we're going to invite you to join us with some of your questions, and you can see over on the GoToMeeting or GoToWebinar rather control panel that you can type in a question, and then that question will be submitted to Tom at the end of the presentation. So if you think of something that you want to ask him as we're going through this, please go ahead and submit that to us, and we'll do our best to answer it. Also, during this webinar, Tom is going to be presenting very interesting slides and material about servo worm reducers. Some of it's going to be in depth for you engineer folks out there. And so please stick around to the very end and make sure that you can follow all the way through on our presentation today. So that being said, I'd like to welcome our speaker today. Good morning, Tom. Great to have you on board.
Hello, Gary. Good morning. Thank you very much. I look forward to having the opportunity pardon me, to share some information and about our high performance servo worm. And we want to thank Power Transmission Engineering for hosting this webinar, and look forward to talking to the audience. Hello, everybody. Good morning. And thanks for taking time out of your schedule today to learn more about our high performance products. We look forward to sharing some information with you. You might not have been aware of it. And as Gary mentioned, toward the end of the presentation, we certainly look forward to fielding your questions and responding. If by chance your question is very lengthy, we may respond back to you. Excuse me. We will certainly respond back to you via email, or if you send us your phone number, we'll be glad to chat with you one-on-one. So with that being said, allow me to dive into the information on our product.
Now, Tom, before you do that, let's just make sure that everybody knows a little bit more about you. Now, we know here at Power Transmission Engineering that your product management experience includes working with both internal and external sales groups and channel partners, developing strategies and programs for new product rollouts. But I have this feeling that sales is not your only responsibility there at DieQua. Is that correct?
Yeah, Gary, you're correct. With about 40 years of experience within factory automation, I've had the pleasure of working, supporting, and commissioning a pretty diverse range of programmable logic control, automation, and process control systems, servos, steppers, variable speed, multi-speed AC and DC solutions, as well as inspection, automatic identification, and detection. So that very broad and diverse range of product and application commissioning really helps DieQua bring the best possible solutions to our customers' applications and needs.
Thanks, Tom. Let's go ahead and dive into what you have for us here today.
All right, Gary, thank you. So the product we're going to be concentrating today on is DieQua's high performance servo worm reducer. What makes this product unique is a number of things. The ability to function well within a servo type environment. And what I mean by that is that this reducer is capable of responding up to acceleration speeds of 6,000 RPM. Certainly it can handle much lower speed. And as we'll learn shortly, It's also capable of very high efficiency, and that's one of the misconceptions about servo worms. Additionally, by part number, this product has the range of expert version of less than 1 arc minute of backlash, in its medium iteration less than 5 arc minutes, and in a basic configuration for applications that don't require that same degree of efficiency or performance in a basic or a less than 10 arc minute backlash. In the case of reduction, we have 9 exact ratios from a 5:1 through a 90:1, and 14 sizes available starting at a size 25 all the way up through a size 110, with capacities through 7,800 Newton meters. To complement many of the applications that we're called upon to assist with is a very broad range of multiple output configurations. Among the most popular is a hollow bore with a shrink disc, or hollow bore with a key connection, single or dual shaft. And then the last, which is most interesting for application considerations, is a robot flange with a large hollow bore. And all of these we'll be discussing a little bit further shortly. Performance specifications, a lot of data there. So let's fade out everything but the very specific information we're going to explore. So we're taking a look at our size 45 reducer you see on the left side of the screen. And it's a ratio integer of 10.25 to 1. Because this is specifically a high performance servo worm, I've highlighted the 3000 RPM performance area, and we can see that a nominal acceleration of 53 Newton meters is possible, acceleration torques of 81, and then over on the e-stop column a little further to the right, we can accommodate up to 214 Newton meters. I had mentioned a little earlier about the perhaps misperceptions of efficiency. Here we can see that with a 3000 RPM and a 10.25 to 1, this reducer is 91% efficient. That's a rather significant consideration as compared to what people may have felt, that worm reducers really aren't well suited for servo applications. Clearly, this product is certainly capable of that. If you would take a look over at the far right side of the table, the FR and FA data is the radial and axial support capacities. And because of the construction that we'll be diving further into a little bit from now, we have a radial support capacity of 5,800 newtons and 4,000 newtons of force respectively. And this is a testament to not only the oversized taper roller bearings the product features, but also the torsionally rigid aluminum magnesium alloy housing that is both lightweight and very strong. So in many demanding applications, it's a lightweight, high performance solution. Frequently, we're asked to identify a solution that provides a very compact configuration. So if we take a look at the 3 different configurations of an inline planetary, a bevel planetary, which is a right angle solution, you can see in the inline planetary, it is by its inherent nature very long. Also, in that you've a stacked accumulation of both the reducer and the length of the servo motor intruding out into floor space. There also may be some mounting or structural considerations that can be an issue as well. When we look at the right angle bevel planetary, initially you might assume because it's a right angle solution, it's more compact, but because that second stage happens to be the planetary, we're still well off of the side of the machine frame. Now looking at the high performance servo worm, we can see that it is tucked immediately adjacent to the machine frame, greatly reducing any floor space that it might occupy. It helps to shrink the envelope of the machine. Because the product is a single stage iteration, we're generally the same width as the servo motor. So we're looking at a product that is anywhere from 100 to 180 millimeters, or roughly 4 to 7 inches in width. Again, pretty typically the same size as the actual servo motor that it's interfaced with. We can accommodate motor input shaft sizes from 6 to 42 millimeters. And of course, we can provide custom interface solutions as well. When we speak about the respective frame sizes of the worm reducers, generally we are talking about the input center line to the output center line. And in the case of our high performance servo worm, this ranges from a 25 millimeter all the way up through a size 110, or roughly 1 inch to about 4 inches. So again, in a single stage configuration, very compact, dense reducer solution. Talking a little bit about the output capability. Pardon me. As I mentioned, one of the most popular solutions is a hollow bore with a shrink disc connection. What makes this the most popular configuration is that our output shaft actually compresses around your application's machine input shaft, providing 360 degrees of full connection. Important note here is that shaft tolerancing, which would be to a capital H7 ISO standard, further the shaft preparation, clean, free of any debris, cleaned with a solvent to make sure that there is no lubricant present when the connection is finalized. One last thing is people look at the shrink disc, because we are actually compressing our shaft onto your input shaft, it is important to note that the actual tightening sequence is circular rather than the automotive approach to a star pattern. This ensures smooth, easy interface between the shrink disc compressing our shaft onto yours. A more basic configuration, more simplified, is a hollow bore with key. This would then require your input shaft having a key connection. This being the most basic, we rely on torque transmission of the key face sides rather than a 360-degree connection. But again, some applications that require more simplicity, this is certainly a desirable approach if cost is a consideration. Next, we have the dual shaft, either single or dual. These are steel output shafts, and it's available either as a single or a dual. And in this case, we offer them in steel. We do have customers that have special requirements, and these output shafts can be also provided in a stainless steel offering. I mentioned earlier a little bit about our robot flange with a large hollow bore configuration. The robot flange conforms to the ISO 9409 standard for robotic accessory interface. That means that pretty much anyone in the industry can grab a standard accessory. This will easily mount directly to the robot flange. An interesting application consideration, I had earlier mentioned about the large oversized taper roller bearings. Orienting the reducer on its side permits the application of a dial table to this. And because of that large hollow bore, plumbing, power, fiber optics, so forth, can pass directly through the center without the need of a rotary union, giving the application further flexibility. So we've taken a look at performance specs, some of the output configurations, what makes this reducer a far more functionally high performance product. And so we're going to dive a bit into what is the construction that lends the reducer to meeting your demanding needs. So the first we're going to take a look at the worm shaft. Unique to the industry is a dual compound ground worm and ring gear. And as you can see by this graphic, moving from left to right, the worm flanks are ground to go thicker to thinner. During assembly that we're going to take a look at next, you'll see how this facilitates being able to offer this product with a less than 1 arc minute configuration, and that's set up during assembly and verification of Backlash spec. You'll note also that the worm shaft has a highly ground or polished finish. This is done to ensure longevity, and this is also true with the proprietary bronze alloy ring gear, delivering up to 20,000 hours of operational life. I mentioned that with the reducer, the expert version that has a less than 1 arc minute of configuration, this is accomplished during the assembly process, and the blue arrows indicate as we assemble the worm shaft into the reducer, the preload and the positioning of the worm is controlled by a shim pack that allows us to establish and maintain that less than 1 arc minute. And we'll be also exploring the bearing structure that helps maintain the alignment of that worm shaft relative to the ring, delivering consistent backlash performance. So we talked a little bit about how we put the worm shaft together with the ring. Now, what is it that helps us maintain alignment? As you're probably aware, worms generate a fair degree of heat due to the sliding friction between the worm shaft and the ring gear. In order to maintain proper position and alignment, we employ a 3-bearing support structure. On the left side of the graphic, you can see the 2 opposed taper roller bearings, and this is affixed via the bearing end cap that establishes preload. This is also where we validate the backlash being at less than 1 arc minute. On the opposite side of the worm shaft is a radial ball bearing that can axially float within a thermal pocket. This helps to maintain very precise position of the worm relative to the ring gear, and it ensures that we are capable of accommodating that 6,000 RPM. You'll also notice a stainless steel coupling, zero backlash bellow design, and that I'll talk about a little further in the next slide, helps to manage any thermal growth that might occur on the worm shaft from loading the servo motor. When we look at adjusting the backlash for the gear set, we utilize a pigmented assembly lubricant. This helps to ensure that we have proper position of the gear, but it also indicates that we are utilizing better than 90% of the gear face Because worm reducers also possess a very high shock load tolerance, in the case of our high-performance servo worm, we, by utilizing that high percentage of the gear faces, we have a higher longevity and are able to deliver much closer precision as compared to one of our competitors, where they're repeating over a much narrower area. And you can see it's concentrated on roughly 40% of the ring gear's contact area. This speaks to performance, tolerance, and backlash in comparison to our high-performance servo worm. I mentioned the thermal expansion that could possibly occur from friction-generated heat on the worm shaft. We isolate any axial growth from impacting the servo motor with that torsionally rigid stainless steel zero backlash coupling. We also prevent the motor from also loading us in the opposite direction. And you can see with the, additionally with the servo adapter that we have available, we have a very wide library of motor adapter flanges available. One of the questions we frequently hear is, whose servo motors do we typically interface with? Well, being a reducer manufacturer, the short, quick answer is everybody's. So we do have a broad library of standard interface and connection solutions, but we can also provide custom solutions both in the coupling to accommodate a very wide range of motor shaft lengths or configurations, and that's also true with the motor adapter flange as well. To help support the different types of output configurations that are available, the oversized taper roller bearings are utilized on all of our output shafts. And from a radial standpoint, we have a capacity starting at 1,500 newtons, and that runs through 21,500. In axial loading issues from 500 to 16,000 newtons. And in the case of the robot flange, from 250 to 3,900 Newton meters. So we have designed into this system the high performance capacity generally suited for many of the applications in the market. The aluminum magnesium alloy housing is machined in a single setup. This ensures performance or consistency of engineered tolerances. And you can see from this photo, multiple through holes for mounting the reducer onto a machined pilot that has drilled blind tapped holes. And on all of the surfaces, those same mounting holes are available. So you have a very broad range of mounting solutions available, whether it's a direct connection or mounting direct connection onto the shaft, or actually physically mounting the reducer directly to the machine frame. So we've looked at why this gearbox is unique, the high performance capabilities and the elements that lend it to a pretty diverse and broad range of applications. We're going to explore a little bit about some of the applications where our high performance servo worm is utilized. And in this graphic, this is a overbraiding application where the wire feed passing up through the center element of the carriage, and then the overbraiding is putting a protective weave onto the wire. Some of the critical considerations for this is the need for smooth operation, a synchronization of the draw of the wire, and then the weave of the overbraiding. Again, very critical to provide smooth, even torque without any fluctuations or variation between the camming function of the primary feed to the carriage's rotation. In this application, we're looking at a sheet feeder for a printing application. The high cycle rate that we're called upon to feed, there is some variation by the master command, and our ability to quickly respond to smooth and accurate velocity match to feed the paper into and through the system, again, with the highly efficient reducer, well-polished machined worm and ring, we're able to ensure that we're providing a smooth operational flow. This application was kind of fun, I guess if you can call an app fun, where it was a theatrical performance where it was a limited space of the stage. So in that center 18-foot dial, they actually had 3 different scene views, and we had to smoothly transition each 180 degree move with actors on the stage as silent as we possibly could. So we were driving the dial from the circumference configuration because worm reducers are among the quietest of reducers out on the market, ours being in the 55 dB arena. The actual servo and reducer during the silent portion of the performance could not be heard, meeting the needs of the artistic director. That was kind of a fun application. Somewhat more demanding application, this happens to be a marine-borne satellite communication system. For those that might be familiar with dish-type systems, you have a wind loading consideration depending on the diameter of the dish. So the reducer needs to not only accurately maintain and position the dish both in azimuth and in elevation, we also have to contend with any of the buffeting that's induced by wind load and any type of movement of the ship regarding the wave interaction with the vessel. So with the aluminum magnesium housing, the output shafting was converted from standard steel to stainless steel to address any of the corrosion elements of the environment. This type of application, not only for marine applications, but also for stationary or ground-based satellite communication systems, also have that same buffeting or wind load issue to take into consideration. The design of the reducer lends itself to supporting this type of an application. This application was pretty much positioning, collating, and positioning. The most compelling element of the design for this application, smooth operation, certainly, but to provide a more compact configuration, again, to get the reducers from projecting out into the floor's workspace, but to get them tucked in as close to the side rails of the machine as possible. And in this configuration, we were actually using shrink disc to further help ensure a solid connection to the drive shafts on the machine. Here in this machine tool application, were a number of reducers used both in conveyor feed of the parts into the system, but also to assist in internal positioning. Because of the compact size of the reducer, also the option of number of different output shafts, we actually were able to use one size reducer, but with different output configurations to meet the needs of the machine tool. Also, because of the presence of the water-based cutting or cooling fluids, the reducer configured to an IP65 worked well in this application. Conveyor and, in this placement, we're actually driving the conveying system because we had to help get the system as compact as possible, again, the 4 to 7 millimeter width on the reducer lent itself to meeting that expectation, as well as a smooth acceleration deceleration profile to help positioning the product. When we look at linear motion type applications, we're frequently called upon to couple either directly to a tangential belt drive shaft, sometimes a leaded or a screw shaft type application. These are predominantly showing horizontal movement. One of the things that's interesting to note about worm reducers is that in ratios, if you have an application for a vertical configuration, in ratios greater than 40 to 1, they are considered non-back drivable. So that if you have a long belt-driven actuator and you need to take advantage of that non-back drivability during a vertical descent, the reducer will help decel the load. It also helps reduce the amount of brake that is needed on the back end of the servo motor. So ratios greater than 40 to 1, non-back drivable. In ratios less than that, they progress from semi-back drivable to fully back drivable, typically below 15 to 1, so that the load could overhaul the motor. But greater than 40 to 1, non-back drivable. We're typically called upon to provide reducer solutions in linear applications where a rack and pinion system is utilized. And here's an example of a roller pinion system or a helical pinion. There's also an iteration where it's a straight cut or a spur pinion. Among the forces, not only do we have to generate rotational force, but we also have to resist any separation force induced by the roller pinion or the helical or spur cut. In the case of the helical cut pinion, in addition to the radial or the moment load that we might be seeing, there is axial force that we have to take into consideration. Those oversized taper roller bearings speak well to addressing those performance issues as well. So with the robot flange interface, it allows us to directly connect these pinion solutions directly to our output shaft. The application of those designs frequently are used in a robotic pick and place system where the robot may traverse a very long workspace, and generally the reducer runs directly with the robotic system. Because of the lightweight aluminum magnesium housing and the mechanical support capacity, it functions well where weight and high performance, high accelerations are typically the demand from the app. Few extra applications. Here is a packaging system that provides an overwrap. Generally at the top portion where we're rotating the arm, we need a low profile, high performance, very durable mechanical solution, and both in the vertical movement of the film carriage and the rotation of the arm, having a hollow bore with a shrink disc and a very compact housing lends itself, in addition to being lightweight, to help reduce some of the demands on the loading and the construction of the application. One of the last applications we're going to look at is a dial table, as I mentioned earlier. With that hollow bore system and that robot flange, customers can create their own unique movement profile because we're utilizing the encoder on the back of the servo motor, not relying on a fixed station traditional cam indexer. You can provide the application or your customer's application with enhanced frequency of positioning of the workstations not limiting by the traditional cam indexer. And again, that large hollow bore interface allows us to actually get plumbing, fiber optics, pneumatics up through the center without needing the use of a rotary union. Reduced dimension, taking a look at some of the benefits of the high performance worm, lightweight housing, strong torsionally rigid housing, lightweight, a number of different mounting configurations for outputs available, the ability to interface to pretty much any servo motor out on the market. The high performance servo worm really lends itself to many different diverse applications. Frequently, we get called upon to perform in a variety of applications. This is somewhat of a general list of where we do get called upon. Because this product lends itself to also being highly customized, we are able to complement your design applications or the criteria that an off-the-shelf solution might not suffice. We welcome the opportunity to chat with you about those further. So, in conclusion, 9 sizes available, starting from a size 25 up through a 110, or about 1 inch up to 4 inch separation input to output, 9 exact ratios, a wide range of backlash options to interface well for the application you're trying to accomplish. I appreciate the time you guys have spent with us today. I appreciate hearing from you. Here is my phone number and email contact, and we welcome your questions.
Great, Tom. Hey, thanks very much. I'm still always amazed at just the various ways DieQua's products are being used out there in the world because of that versatility. And this particular invention, the servo worm reducer, sure seems to fit in a lot of places, doesn't it?
It does. We, as I mentioned earlier, the first hurdle sometimes we have to overcome is, why would I want to use a worm in an application with a servo? Well, I hope that we've maybe dispelled some of the myths that might exist and shared some of the applications, certainly very demanding ones, that we've been able to help customers with.
Absolutely. So just to clarify, you said that you can interface to any of the motors that are out there. Can you also help customers with the control systems that are program the operation of these devices?
We can certainly assist with the selection and the identification of the correct interface, but we recognize that with the broad range of motion solutions that are out there, we can help with reducer solution, but we also don't want to trip into areas where our folks who are our regular customers are actually performing that solution. So we certainly provide expert engineering assistance in the selection and identification of the product. But as far as controlling it, one of the interesting things about the servo worm reducer is that the ratios lend themselves to helping perform very accurate positioning, because it's an even value between input to output, which really does lend itself to very precise positioning.
Exactly. So this is, I think, another good example of DieQua and your team there, Tom, teaming up and partnering up with other companies to provide complete solutions. So thank you very much for that. I do have a question coming in from one of our attendees here, and that gentleman asks, what type of application or industry would you recommend a substitute gearbox, and what type of gearbox would that be?
When we look at applications, the first thing that we want to understand is, what is the expectation the machine is expected to perform. When we look at where a servo worm reducer may not be the best solution, and that typically falls into the category of very, very high frequency stop-start or bidirectional application. When we look at the performance efficiency of a servo worm, and in the case of the size 45 with a 10-to-1 ratio, we know we can accommodate anywhere from 3,000, well, as low as 1 RPM up to 6,000. But if we're frequently at very low velocity, we might want to look at a reducer that employs a different gearing technology, whether that's one of our planetary solutions that has a much smaller inertial load, or if it requires much higher torque capacity, we can accommodate applications up to 14,000 Newton meters. So generally, because of the range of gearing solutions that we do have to offer, we aren't pigeonholing a customer into a single given technology. We can offer many different gearing technologies or system configurations.
Understood, and DieQua has a lot to offer anybody that's looking for this type of gearbox device. Let's see, we've got on the line here with us Alex Malamos, and Alex,
hello. We've got one good question here that's asking, what is the biggest misconception about these type of boxes that really serves as a hurdle from utilizing them in an application?
Alex, that was a good question, and frequently it is the efficiency that we get asked about, but also the construction of the worm. Because we have worm solutions that are not only this high performance servo worm, but a more standardized industrial worm that's been configured to also function with servo motors, we want to make sure that we well understand the acceleration, the motion profile, the duty cycle that the reducer is going to be called upon to perform. We know that in the standard industrial worms consideration, we typically don't want to utilize something that has a sustained high-speed input velocity, and where the high-performance worm, the worm shaft with that 3-bearing support structure and its preload is certainly better suited to handle high-speed acceleration. And that number typically is about on the standard industrial worm is about 2,000 RPM of acceleration input. In the case of the high-performance worm, that is in the arena of 6,000 RPM. Of course, there are applications where we also might need to address thermal applications either by frequent stop-start or the environment itself, and we can assist in modifying the lubricant system to accommodate any temperature changes we might have to address as well.
excellent, Tom, thank you. So, gentlemen, on our attendee list here, those of you that have enjoyed this presentation by Tom Kahn, now you can reach Tom over at DieQua, the Director of Motion Products, by phone at 630-622-2132. Tom will welcome your phone calls, and also feel free to send him an email at tkahn, T-K-A-H-N, at DieQua.com. So that'll be a great way to follow up on this. We are recording this presentation, and it will be shown later today or tomorrow morning. It'll be available on the Power Transmission Engineering website. So if you want to share it with people in your company, you're welcome to come over to the PTE website and enjoy it there, the recording of it, replay it at your convenience. And also, Tom has provided a handout, the Motion Products Flyer by DieQua, and you can get that right now here on the control panel by just going down to the handout tab and clicking on that link to that document. And you can pull that down, and that's got additional information plus Tom's contact number on it. So Tom, with that said, I think that's about a wrap up here. Thank you so much for your high quality presentation here. It's, DieQua sets the bar high for everybody here, and we sure appreciate your taking the time out of your day to share this information with us.
Gary, our thanks to you and to Power Transmission Engineering and to all the attendees. We certainly respect the fact that you have great demands on your time, and we appreciate your being here. Please feel free, the motion product selection guide that Gary had mentioned, feel free to download that. One of the other questions that is presented to us is, can DieQua provide custom solutions? The answer is absolutely. We certainly welcome standard off-the-shelf inquiries, but we can, to small volume, 1, 2, 3 pieces, provide customized solutions. Feel free to reach out to me or to anyone here at DieQua, and we welcome the opportunity to be of assistance. Thank you again for your time. Gary, thank you.
You bet, Tom. And everybody have a great day out there. Stay healthy and well. And we look forward to having you join us at our next presentation. Thanks so much and have a great day.